Okay, good morning, ladies and gentlemen. Now we continue on with solving multi-step linear equations. Yesterday you dealt with two-step. Now you're dealing with multiple steps, so it's going to get a little bit harder. All right. Now, first some terminology we need to go over. Number one, like terms. Terms that have the exact same variable raised to the exact same exponent, or the terms that have the same variable and exponent value. Okay. The examples I have here are, you see that we have a negative 7x and a 3x here. They both have the same variable of x, and they both have the same exponent value of 1. Here, you have two numbers, 10 and negative 135. Those are like terms because they're both numbers. However, looking over here at the non-example, x minus 2, x minus 2, negative x squared, wow, is not the same as 5x. And the reason for that is that this exponent value of 2 is different from this exponent value of 1. It has nothing to do with the fact that this is negative and this is positive. As you can see over here, negative 7x and positive 3x are like terms because they have the same x to the exponent 1. This has an exponent value of 1, while this has an exponent value of 2. Now, with like terms, we can add and subtract them, which is what we were kind of doing yesterday with solving for x in those two-step linear equations with the constants. Okay? Remember that. Next thing we need to go over is the distributive property. And the distributive property states that multiplying a term outside the brackets to every term inside the brackets. So think of like a dealer at a poker game. The dealer can only deal cards to people sitting at the table. So this negative 3 can only multiply to terms inside the brackets. In this case, the x and the negative 4. So when you take negative 3 times x, you get negative 3x, and negative 3 times negative 4 is positive 12. The reason why this step is starred is because it's unnecessary. You do not have to write this. I'm just explaining how the distributive property works. Okay? So now let's look at trying to solve for x using multiple steps and these properties that we just talked about. So my first example is I want to use 3 times x minus 1 plus 1 is equal to 5 times x minus 2. So when we're trying to solve for x, we need to clean this up because we've got multiple steps. We need to clean it up. In this case, we should look to do the distributive property right here with the 3 in the x and the 3 in the negative 1. We cannot go 3 times positive 1 because this positive 1 right here is outside the brackets. So that's invalid. It can only deal cards to people sitting at the table. Same with the 5 times x and the 5 times negative 2. Though that's valid, but this 5 doesn't magically come over here and multiply that 1. So from here, 3 times x is 3x, 3 times negative 1 is negative 3, then plus 1, which is then equal to 5 times x, which is 5x, and 5 times negative 2, which is negative 10. Now, at this point, we want to get all the variables on one side and all the x's on the other. So just to explain here, first we did some BEDMAS to clean up, and now we're looking to collect like terms. But before we start, doing some weird, crazy math, when I say collect like terms, look at the left and right side here. Okay, are there terms just on the left side of this equation over here? Is there any terms here on the left side of this equation by itself that are like terms? And hopefully you can say yes, absolutely, Mr. Michaud. This negative 3 and this positive 1, those two are like terms. So we should collect them first. So 3x, negative 3 plus 1 is negative 2. While on the right side, 5x and negative 10 are not like terms, so we're just going to leave them alone. I do this because we don't want to make some crazy errors. I've found in years past, students will try to move a bunch of terms from left to the right side and make mistakes. So this is how I'm trying to limit our mistakes here. Now if you look, we highlight the like terms here. We have a negative 2 and a negative 10. Those are like terms. We have a 3x and we have a 5x. Those are like terms. But you see that they're on different sides of the equation. What we now need to decide is which side you want the x's on and which side you want all the numbers on. Just for fun, I'm going to put all the numbers on the left and all the x's on the right because we need to solve for x and we need to collect like terms. So it's the same thing here. So to get all the x's on the right side, we need to do opposite operations, and we do that by the opposite of positive 3x would be minus 3x. When we're collecting like terms, we add and subtract. So we're going to subtract both sides by 3x. So we're left with now negative 2 equals 5x minus 3x is 2x. So 2x minus 10 is on the right side. Now, looking back here, we want all the numbers on the left, and we said negative 2 and negative 10 were like terms, so the opposite of minus 10 would be adding 10 to both sides. So on the left side, 10 take away 2 is 8, and negative 10 plus 10 is nothing, so we're just left with 2x. Now we have an easy one-step equation to solve for x, and we just simply divide both sides by 2. So 4 equals x, or x equals 4. Okay? That's one kind of equation you'd face. A second kind of equation you'd face is something that involves fractions, and fractions can be can be a little bit tricky, as you know from the unit test we did with standard form and slope y-intercept form. So let's try one. We've got x plus 3 divided by 8 plus x plus 1 divided by 3 is equal to 3. Now, fractions, you're looking at this question going, don't get it. I know. It's because of those darn fractions. I know. So, we have to find a way to get rid of them. And if you recall from the unit test, when we went from slope y-intercept form to standard form, we can get rid of fractions. We can get rid of the denominators by multiplying both sides by the lowest common denominator. The LCD. So we look at our two denominators we have here, 3 and 8. Now we can list the multiples of 3 and 8 and figure out when we have a pair. In this case, it's 24. Now, you might be saying to yourself, well, I could just go 3 times 8 and that'll always work. We'll have a common denominator. Yes, you will always have a common denominator if you take all the denominators and make them a product of each other or multiply them all together. The problem is that that may not always be the lowest common denominator. In this case it was, but don't always rely on multiplying by denominators. So since the LCD is 24, I'm going to multiply every term by 24. Okay? So I'm just going to take, I can't do that. All right. So 24 times x plus 3 over 8 plus 24 times x plus 1 over 3 is equal to 24 times 3. Why do we do this? Well, it's all about cross-canceling or doing division to get rid of those denominators. So you look at the 24 and the 8 specifically. This here. Well, how many times does 8 go into 24? 3 times. And then 8 divided by 8 is 1. It's now gone. So I'm now left with 3 times x plus 3. Here, 24 divided by 3, well, that's 8 over 1. So now I'm going to have plus 8 times x plus 1 is equal to 24 times 3 is 72. And now this question is just like what we did in the previous example. Doing distributive property, getting all the x's together, collecting like terms, and then getting all the constants on the other side and solving for x. In this case, we take this 3 and it multiplies to the x and the 3. It does not go all the way to the 72, nor does it have anything to do with any term in the middle. The 3 can only deal cards to the people that are sitting at the poker table. In this case, inside the brackets with x and 3. So that's 3x plus 9. 8 multiplies the x and the 1, so that's 8 times x, which is 8x, 8 times 1, which is 8, and then 72 is still 72 on the right side. Now, as I said before, we need to collect like terms on one side specifically. If you have any like terms on one side, collect them first before we start doing opposite operations to get all the variables on one side and all the constants on the other. So we can see right away that we have a 3x and an 8x. The sign is always attached at the hip. They are like terms. And this 9 and this 8 are like terms. So what we can do is we can go, all right, 3x plus 8x is 11x. 9 plus 8 is 17, and that equals 72. So now at this point, we need to decide, which side do we want all the x's or variables on, and which side do we want all the constants or numbers on? Which side do we want all the numbers on? In this case, there's only one x term now to deal with, this 11x. So why don't we just leave all the x's on the left side here? Because we have, as you can see, a 17 and a 72. So let's put all the constants or numbers on the right side. I write this just because it keeps it straight in my head. So if I want to get all the numbers on the right side, this positive 17 on the left side needs to change. So the opposite of adding 17 will be subtracting 17. So I'm left with 11x, which is equal to 55. And then this is a one-step equation now. So we have 11 times x. The opposite operation is to divide by 11. So 11x divided by 11 is x, and 55 divided by 11 is 5. And that's how you do multi-step equations. Okay? Got your questions for today. Be prepared for your quiz. We'll see how this goes, but you should be having a quiz tomorrow. Unless it's tricky, we'll see how this goes. Have yourselves a great day. Thank you very much.